Hello, in this video we will discuss some basic concept of a data warehouse and what is a data cube and what is OLAP means online analytical processing. If time permits, we will also discuss how to design a database and how to use the database and how to implement a data warehouse. So basically, what is a data warehouse? So different authors defined data warehouse differently. So the exact definition we don't know. Based on the requirements, the definition may be vary. So a decision support database that is maintained separately from the organization's operational database. So every organization has some operational database which records day-to-day operations, but the data warehouse is separate from that operational database. So support information processing by providing a solid platform of consolidated historical data for analysis. As WH Inman, the definition of a data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data that supports management for decision-making process. So now we will see what is meant by subject-oriented, integrated, time-variant, and non-volatile data means. So a data warehouse is the process of constructing and using a data warehouse. So as we discussed, a data warehouse is a subject-oriented means unlike operational data, the data warehouse concentrates on the subject rather than day-to-day operations. The subject may be a customer or a product or sales, etc. So it focusing on the modeling and analysis of data for decision makers, not on daily operations or transaction processing. Means that the data warehouse doesn't record or it doesn't contain day-to-day operations like OLTP, which contains day-to-day transactions regarding various things like purchases, sales, like that. The data warehouse doesn't contain OLTP operations. Instead, it stores historical data for data analysis. So the data warehouse provides a simple and concise view around particular subject issued by excluding data that are not usable in the decision support process. So the data warehouse is integrated, means we will build a data warehouse by integrating multiple data sources and heterogeneous data sources. For example, we may combine relational databases, some flat files, some online transaction records. All these will be clubbed to form a data warehouse. When we are clubbing all these files, some process is required, that is data cleaning. After performing the data cleaning, the data integration will be done and the data in the data warehouse will be stored. Why we need to perform data cleaning means when we are clubbing database files from different sources, we may face some problems like inconsistent formats, inconsistent naming conventions, some inconsistent encoding structure. Means the naming conventions from different sources may be different. We need to club those under one roof. Then we can able to analyze the data. For example, the hotel price, the currency may be, if the hotel resides in US, the currency may be in dollars. If the hotel resides in India, the currency may be in rupees. So when we are clubbing this data, we need to convert either US dollar to Indian rupees or Indian rupees to US dollars. So in this way, we need to perform data cleaning before integrating the data from multiple sources. Several examples are currency, tax, breakfast, etc. When data is moved to the warehouse, it should be converted. Then only we can analyze the data without any errors. And data warehouse is time variant, means unlike operational data, the data warehouse contains data for longer period of times, so longer than the operational database systems. So operational database systems contains current data, whereas the data warehouse contains information from historical perspective, maybe from past uh, 5 years, 10 years, 15 years, 20 years, etc. So the data warehouse contains historical data, whereas the operational database contains current data. So every key structure in the data warehouse is a data warehouse contains an element of time explicitly or implicitly, but the key of operational data may or may not contain time element. And the data warehouse is non-volatile. So a physically separate store of data transformed from the operational environment. When we are when we are storing a data in data warehouse, it is separated from the operational database. So the operational database is different from the physical data warehouse. Operational update of data doesn't occur in the database environment. It does not require transaction processing, recovery management, and concurrency control mechanisms. Unlike OLTP databases, means which stores transaction information, uh, we have to maintain some recovery mechanism and concurrency control mechanisms. But for data warehouse, those mechanisms are not needed because it stores the historical data rather than the current data. So it requires only two operations in data accessing, that is initial loading of data and access of data. Now we will see what are the various differences between online transaction processing and online analytical processing. Online transaction processing means consider it is a regular database which stores day-to-day transactions. Online analytical processing means it is a data warehouse. It is used for knowledge mining. So the differences are the typical users for OLTP online transaction processing is, for example, maybe clerk, IT professional, etc. Whereas for OLAP, knowledge workers, maybe managers or any high level management, etc. The function of OLTP is to store day to day transactions, whereas the OLAP is used for decision support systems. The database design for OLTP is application oriented, whereas OLAP is subject oriented rather than application oriented. The data in the OLTP transactions are current data and up to date data. It is detailed and flat, relational and isolated, whereas the OLAP data is historical and it is summarized, multidimensional, integrated and consolidated data. The uses of OLTP databases are repetitive, whereas the OLAP is ad hoc. So typical operations performed on OLTP are read-write operations or index hash on primary keys. The typical operations on OLAP are lots of scans which requires some time to execute. The typical unit of work of OLTP is simple and short transactions, whereas OLAP is complex. OLAP unit of work is complex compared to OLTP transactions. The typical records we will access in OLTP may be in tens or hundreds of records, whereas in OLAP, to analyze the data in the data warehouse, you will access billions of records. The number of users may be limited to some hundreds to thousands in OLTP transaction databases, whereas for data warehouses, that the number of users are restricted less than OLTP users, maybe hundreds or tens of users will use the OLAP data warehouses. The database size of OLTP transactions may be 100 MBs to some GBs, whereas the data warehouses contains huge amounts of data, maybe 100 GBs to some terabytes of data. And metrics, we measure the transaction performed on OLTP databases as a transaction throughput, whereas for OLAP databases it is a query throughput, or the response means what time it is taking to give that analysis result. So these are the various differences between OLTP and OLAP databases. So now the question arises, why we need separate data warehouses? We are already using databases, then why we need a separate data warehouse? So to use separate data warehouses, we have so many reasons. So high performance for both systems. For example, DBMS, it is tuned for OLTP transactions, access methods, indexing, concurrency control, and recovery. Whereas a data warehouse tuned for online analytical processing, complex OLAP queries, multidimensional views, and consolidations. We will further discuss what is multidimensional view, like etc. But these are the main differences between regular DBMS, means OLTP, and for data warehouses. So different functions and different data are. So missing data. Decision support requires historical data which operational databases do not typically maintain. So decision support requires historical data which operational databases do not typically maintain. So we need to fill missing data. That data may be useful for analyzing databases. Next, we need to consolidate data. So data store requires consolidation, means we will perform some operations like aggregation, summarization of data from heterogeneous sources. We need to maintain data quality to for analyzing data warehouse. Different sources typically use inconsistent data representations, codes and formats, which we have to be reconciled, means which we have to convert those formats into unique format. Then only we can analyze the data, which gives qualitative analysis. So consider before doing all these things, note that there are more and more systems which perform OLAP analysis directly on relational databases. So this is the typical warehouse structure. It is a multi-tied architecture. So in this we have 3 tiers, or you can say 4 tiers, but we will neglect the first tier, that is data sources, and we will consider remaining 3 tiers. So in the data from different data sources will be combined to form a data warehouse. For example, before constructing a data warehouse, we need to combine data from different data sources. After that, when we are combining data from different data sources, different operations should be performed. for data cleaning, like extraction of data, transformation of data, data loading, and data refresh. So after combining all this data, the data will be stored in the data warehouse. Along with the data warehouse, we will store the metadata which contains data about this data warehouse, and we will also maintain monitor and integrator to monitor metadata and also for data warehouse. For simplicity, the data warehouse data may be divided into data modes which contains some specific sections of data. For example, if it is an enterprise data, it contains maybe the data belongs to some part of this whole database, some part of this whole database. Like that, we may maintain several data modes. So after constructing this data warehouse, we will send this data to OLAP server. Okay, that OLAP server will analyze this data warehouse data, and it will give results as maybe as analysis, maybe a result for a query, maybe it will generate a report, or it may useful for data mining. Like that, a typical data multi-tied data warehouse architecture will be like this. It contains different types. So the data sources type, data storage type, OLAP engine, and we have some different front-end tools. So in this way, we will construct a data warehouse. We have three data warehouse models. Those are enterprise data warehouses, data marts, and virtual data warehouses. So enterprise data warehouses means it collects all the information about subjects spanning the entire organization, means it contains entire organization's data. So data mart, previously we saw what is a data mart, means it contains not the entire organizational data, instead it contains a subset of corporate wide data that is of value to a specific groups of users. Its scope is confined to specific selected groups, such as suppose marketing mart or a sales data mart. Like that, it is a subset of entire corporate wide data. And the data marts also, we have categorized the data marts into two types, like independent data mart and dependent data mart. Dependent data mart is directly derived from the data warehouse. And also the third one is virtual data warehouse, a set of views over operational databases, means it is not actually present in a data warehouses, but the virtual view will be created on operational databases. Only some of the possible summary of views may be materialized. So when we are getting data from different sources and we are constructing data warehouse, we need to perform some pre-processing steps. The pre-processing steps are data extraction. After that, we need to clean the data. After that, we need to transform the data. After that, we need to load and refresh the data. Data extraction means getting of data from multiple sources. The sources may be heterogeneous and external sources. After that, we need to perform data cleaning to avoid errors. We need to detect errors in the data and rectify them when possible. Data transformation means convert the data from legacy or host format to data warehouse format. For example, converting US dollar to Indian rupees or Indian rupees to US dollars. Next, we need to load the data. We need to sort, summarize, consolidate, compute use, check integrity, and build indices and partitions of data. Need to refresh the data after performing all these operations. Propagate the updates from the data sources to the data warehouses. So metadata repository means metadata is nothing but the data about the data warehouse. It also contains some information which is not useful for our discussion. Next, we will see what is a data cube and what is online analytical processing. So data cube is nothing but a representation of data in multiple dimensions. The dimensions may be one dimensional, two dimension, three dimension, four dimension, etc. We will see how to maintain the data in multiple dimensions and what is a data cube and what is online analytical processing. So in traditional databases, the data will be stored in the form of tables, in the form of relational tables and spreadsheets. From that, when we are constructing a data warehouse, the data is converted into data cubes. So a data warehouse is based on multidimensional data model which views data in the form of a data cube. A data cube such as maybe sales data cube allows the data to be modeled and viewed in multiple dimensions. So the data cube contain dimensional tables and fact tables. Dimension tables such as item, the item may be divided like this: the item name, brand of the item, and item type. Or the time, another dimension time may be divided as day, week, month, quarter, year, etc. So and fact table contains measures such as dollars sold, keys to each of the related dimension tables, etc. In data warehousing literature, an ND base cube is called a base cuboid. The topmost zero cuboid, which holds the highest level of summarization, is called a apex cuboid. So the apex cuboid is nothing but the 0D cuboid. The lattice of the cuboids from a data cube is, for example, before going to multidimensional data, we will see how the 2D data will be viewed. For example, this is the sales data for all electronics. Maybe this is a online electronics mart according to two dimensions, that is time and item. So and the data belongs to the location Vancouver, which is in USA or Russia something. So the data is divided into two dimensions. In one dimension we have item type. That is, item type is maybe home entertainment item, a computer item, a phone, or a security. In another dimension we have quarter one data, quarter two data, quarter three and quarter four data. Okay, this is a two-dimensional data representation. Means it contains two dimensions. In one dimension we have an item type, and in another dimension we have a time type. This is the sales. Suppose quarter one sales of home entertainment of location Vancouver is 605. The data displayed here is dollars sold, means $605,000 worth of home entertainment items sold. Like that, in quarter one, $825,000 of computer items sold. Like that, we need to store the data. This is the two-dimensional representation, and we have 3D data. Observe this. Previously, we discussed 3D data of what the location Vancouver. So this is the location Vancouver. So here one dimension is item and another dimension is time. So same values are there: 605, 825, 14 and 20. The difference between 2D data and 3D data is 3D data is nothing but a collection of two-dimensional data. So these are all two-dimensional tables. So these are all two-dimensional tables. A collection of two-dimensional tables forms a three-dimensional data. So this is the sales data of location Chicago for these particular times, and the sales data of location New York for these particular times, and the sales data of location Toronto for the particular times. Means a 3D view is nothing but a collection of 2D views. Now this is the example for a data cube. So what we see in a previous slide is represented as a cube. In previous slide we saw this one. Now when we are constructing a cube based on this data, this looks like this. So we have a location, we have time in one axis, we have item type in one axis. All the data which is available in these tables are stored here. So this is Q1 data for Vancouver of item, home entertainment, Q1 data of computer in Vancouver. Like that, the data is modeled in the 3D data cube. This is called three-dimensional data cube. Okay, we have different dimension, and each dimension has different purposes. So this is how the 3D data cube will be represented. So now we will see what is a lattice of cuboids. As we saw in the previous slides, so apex cuboid. Cuboid means a data warehouse. In data warehouse literature, an ND database cube is called a base cuboid. If the dimension of that cuboid is 0, then it is a apex cuboid. So the dimension here is 0, so it is called a apex cuboid or zero cuboid, zero dimension cuboid. The dimension of these things are 1, so these are called 1D cuboids. Like that, the dimension of these are 2, these are called 2D cuboids, and the dimension of these are 3, so 3D cuboids. And here it is 4, here it is 4, so those are 4D, sorry, here it is 3, these are 3D cuboids, here it is a 4, so 4D cuboids. Like that, we will represent a lattice of cuboids. So now we will see how to model data warehouses. Modeling data warehouses will concentrate on dimensions and its measures. So we model data warehouses by considering or by using these schemas. So first we will use star schema, a fact table in the middle connected to a set of dimensional tables. So in this schema, a fact table will be maintained, and that fact table, suppose this is a fact table, we have different dimensional tables here. So this fact table is connected to different dimensional tables in star schema. Next we have Snowflake schema. It is also like star schema, but the difference is it is a refinement of star schema where some dimensional hierarchy is normalized into a set of smaller dimensional tables, forming a shape of a snowflake. So both are same, but it is slightly improved than star schema. So snowflake is slightly improved than star schema. What is the improvement means? It is normalized, and some dimensional tables tables may be connected to another dimensional tables. Next, another type of representation is fact constellations, where multiple fact tables share dimensional tables viewed as a collection of stars, therefore called as galaxy schema or fact constellation. That we will see. So this is the example for star schema. So this is the fact table. So the fact table is sales fact table. So it contains this data: time key, item key, branch key, location key, units sold, dollars sold, average sales. So in this fact table, some items may be connected to dimension tables. Here time key is connected to time dimensional table, item key is connected to item dimensional table, branch key is connected to branch dimensional table, location is connected to location dimensional table. Like that, here some items in the fact table may be connected to different dimensional tables. So this structure is nothing but a star schema. So, and the slight improvement of this star schema is snowflake schema. So this is also same. See, we in star schema also we have like this. You have a fact table called sales fact table. In this different attributes or items. So each and every item is connected to some dimensional table. But slight improvement is, so these are normalized tables, and the table the item in this dimensional table may be connected to other dimensional tables, forming a snowflake like structure. So it is called a snowflake schema. The difference between star schema and the snowflake schema is this: in star schema the fact table is connected to dimensional table, but in snowflake schema the dimensional tables may be connected to sub-dimensional tables. Next we have fact constellation schema. So this is the improvement over the snowflake schema. The dimensional tables may be connected to other fact tables. Here we have two fact tables: sales fact table and shipping fact table. So this particular dimensional table item is connected to item key in sales fact table, like that item key in the shipping fact table. So this is how the galaxy shape of data will be formed. So that this is called a galaxy schema, or we can say it is a fact constellation schema. So this is nothing but the concept hierarchy. The hierarchy will start from lower level to higher level. Suppose office resides in a particular city. So the city belongs to some state, the state belongs to some country, the country belongs to some region, and the region belongs to some continent, or we can say all. So this is how typical hierarchies will be maintained. So how we measure data cubes? We have three categories of data cube measurements that is of least important for our discussion. Those are distributive measurements, algebraic measurements, and historic measurements. The examples of distributive measurements are count, sum, minimum, and maximum. And the example for algebraic measurements are average, mean, and standard deviation. And holistic measurements are median, mean, median, and mode along with the rank. So these are the different type of data cube measurements. So how we will view a data warehouse and its data hierarchies. The hierarchies are specified like this. So the day is smaller than a month, a day is smaller than a week is smaller than a month is smaller than a quarter, and quarter is smaller than a year. This is the hierarchy of time. Like that, we will consider many type of hierarchies. Suppose 1 to 10, 1 is smaller than 2, 2 is smaller than 3. Like that, we can able to construct different kind of hierarchies. So this is multidimensional data cube, and we have these are the different dimensions: product, location, and time. And we have several hierarchies like product and the product category. That product comes from which industry. Suppose example, office belongs to which city belongs to which state belongs to which country, and this country belongs to which continent. And for example, time, day is less than a week is less than a month less than a quarter is less than a year. Like that, we will consider different hierarchies to maintain data in the data warehouse. This is the sample data cube which we already see in the earlier pages. So this is a typical database where one dimension contains date, and another dimension contains product, and another dimension contains country. The concept is same which we discussed earlier. So cuboids corresponding to the cubes. So 0 means it is apex cuboid. Like that, we have 1D cuboids, 2D cuboids, 3D cuboids, etc. Now we will see important concepts when analyzing OLAP operations. So the typical operations are roll-up operation, drill-down operation, slice and dice operation, pivot operations, and drill across and drill through operations. So roll-up operation is also called drill-up operations, which summarizes data by climbing up hierarchy or by dimension reduction. Drill down operation is also called roll down operations, which reverses of a which is the reverse process of a roll-up operations. From higher level summary to lower level summary or detailed data or introducing new dimensions. Slice and dice means project and select. Pivot means we will rotate the selected slide data cube. Means reorientation of data. The visualization may be changed 3D to series of 3D planes. Maybe we can able to see different kind of visualizations. So we can rotate the data cube and visualize differently, and we can also able to convert 3D series of data to 2D planes. And other operations include drill across and drill through. Drill across means involving more than one fact table. Drill through means the bottom level of the cube to its backend relational data tables using SQL. So this is the example of a data cubes or a data warehouse that comprises of all these typical OLAP operations. So see, so this is our data cube. In this way, we are performing roll-up operation. So see, in this database we have in one dimension we have locations. The location contains cities like Chicago, New York, Toronto, Vancouver, and in one dimension we have time quarter. The quarter contains quarter 1, quarter 2, quarter 3, and quarter 4. And in another dimension we have types of items like home entertainment item, computer item, phone, and securities. So when we are roll up means we are going for higher levels of hierarchies. Means here the Chicago and New York belongs to the country USA, and the Toronto and Vancouver belongs to the country Canada. We are rolling up means we are going for higher level hierarchy. So instead of cities we are analyzing the data of a country. So this is about roll up. Drill down or roll down means we are expanding, we are going to lower level, or we are expanding the data cube. For example, here it is a quarter 1 data. The quarter 1 is divided into January, February, and March data. When we are going for drill down, like that, quarter 2 data is divided into April, May, June data. When we are going to drill down databases, like that, quarter 3 it becomes July, August, September. Like that, we are going for lower level hierarchies. When we are using drill down operations, we are going for upper level hierarchies when we are using roll up operations. And we have slice and dice operations. Slice means cutting one slice from this data cube. Okay, cutting one slice from this data cube, that is nothing but the slice operation. So here the example is slice for quarter 1 slice. Dice means extracting more dimensions. For example, so this may be a die for, this may be the example of a die. So this is the die for location Toronto or Vancouver, and time Q1 or Q2, and item home entertainment or computer. This becomes a die. Slice means quarter 1 data here. Die means it contains some part of a data cube. Next, so what are various pivot operations means we can able to rotate the slice which obtained in different views. So they are all called pivot operations. So in this way, the data in the data warehouse will be stored, and it will be used for online and analytical processing. So this is about the whole lecture. In the next class, we will discuss how to construct a data warehouse and what are its uses. Thank you.